So I looked at today's and I thought, wait a minute, weren't we doing arithmetic and geometric before? Yeah, but those weren't series. Those were sequences. So what the heck is the difference? The difference is just that you add them all up. So instead of just 1, 3, 5, 7, 9, duh, the next one's going to be 11. And we can write that with u sub 1 equals 1. This weird un equals un minus 1, which means any random term is given by the term in front of it. And then this one seems to be adding 2 each time, right? Plus 2. You guys remember that? That's what we were doing for the last few days, right? Those are called sequences. And you can predict u sub any term. So if I want like u sub 5, that's the 5th term. And what I do is I use this thing on the sheet. So grab that white sheet that you have in front of you. And was it the arithmetic or geometric kind, the one I'm practicing right now? Well, arithmetic is the kind where you add. If you haven't already on your sheet, next to arithmetic, write add or subtract. You can put a plus and a minus by the arithmetic kind. That's the kind where you add and subtract. What is geometric? The kind where you multiply. And if you multiply by a fraction, it's like you're dividing. Well, was this add, subtract? It definitely was, which makes it an arithmetic. So now we're down to only half your sheet. On the sheet, it has arithmetic and geometric. And then underneath arithmetic, it's got this u sub n formula. u1 plus n minus 1 times d. But underneath that, it's got something called s sub n. That's the new one for a series. And that goes like this. N over 2, 2u sub 1 plus n minus 1 times d. That looks similar to this one. Look, it's got a u1 in it, and it's got an n minus 1 times d in it. It's just that there's 2 of these, and you have to multiply by n, which is how many numbers there are, divided by 2. Okay, so it's a little more complicated formula for today. This is today's formula. What you did yesterday was this, or yesterday in terms of class. All right, so I want you to right now do u sub 5 for me by doing u1 plus n minus 1 times d. They came right off the sheet. And everybody figure out what the 5th term would be by sticking the numbers in this formula. All you really need to know is u sub 1, which is on the screen, n, which is what number term we want, which is on the screen, and d, which is the difference, which is on the screen. You just have to find 3 numbers on the screen, put them here, here, and here, and the rest of the stuff we can just copy down. Sonora, what is u sub 1? Okay, it's just the first term. Don't overthink this. So it's what? It's 1. And n is which term we want. Well, I said u5, so that means we want the 5th term, so that's a 5. And then the last thing is d. Vivian, do you know what the common difference is here in this? Plus 2. We're adding 2 each time, so we put a 2 here. Don't put a plus 2, though, because that will make it look like you are adding that d. Look at how it's times right there. That's a formula where you're going to times by the number you add each time. It is a positive 2, but don't put a plus or you're going to think you're supposed to add right there. All right, so then this is 4 sets of 2 get added to 1. 4 sets of 2 is 8 plus 1 is 9. So 9 is u sub 5. And if you just look here, u1, u2, u3, u4, and u5 was 9. Does that make sense? That's the old kind, the kind we just finished learning. So if I asked you to find u sub 10, I want you to do that right now. What is u sub 10? Use the little formula on your sheet, which is right here, by the way, and figure out what u sub 10 is. I'm going to pause for a second. You figure out what the 10th term would be. Notice you just copy that formula. And you stick in the numbers, and it does all the work for you. This test is all about just using the formulas. We're going to give them to you, just like I am right now. I handed you all a white half sheet that's got all the formulas on it. It's just, can you use those formulas? All right, take a minute, stick in all the numbers. I'm going to have you compare with the kid sitting next to you in a moment. Cannot afford to be lazy right now. At the end of the hour, you can be more lazy, but right now, stay focused. Stick in the right numbers here, 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 and you'll figure out what u sub 10 is in no time. Okay, let's see if you did this right. Rena, can you tell me what u sub 1 was?
1.
It is 1. It came right there. It's the first term. 1 plus. And Christian, what was n? 10. Very good. 10 minus 1, which is 9 sets of d, which is a common difference, which was 2. 9 sets of 2 is 18 plus the 1 makes 19. Raise your hand if you had 19. Okay, awesome. That is not a series. That's called a sequence. But the new thing for today is called series. What's the difference? You would add them all up. Let me give you an example in the real world. So Tesla has been making cars now for quite a few years. This year, they're on track. They'll probably make about 2 million cars this year. Okay? The year before that, they made like 1.3 million or 1.4 million cars. The year before that, they made a bunch of cars. So do you get that the total number of Teslas that are out there is the sum of the last several years all added up? Okay, so instead of just saying, well, Tesla made 2 million cars this year, but what about all the cars they made before? So all the Teslas that are out there, by the end of this year, the fleet will be around 5 million, maybe 4 million. 4 to 5 million cars. Because we add up all the numbers, all the previous numbers. So there's a famous problem that I'm going to tell you about, and that was, there was this little genius in Germany. They had a very small schoolhouse, and this little genius guy named Friedrich was, the teacher was just trying to keep him busy because he was just so smart. And they were like, okay, here, Friedrich, would you just add up all the numbers from 1 to 100 just to kind of keep you busy? And so he was like 1, 2, 3, and he was like, this got to be a better way than 1 plus 2, and then you add 3, and then you add 4, and then you add 5. But he didn't do it the way that most of us would. Most of us would be like trying to figure out some pattern that would allow me to add just the beginning of the numbers. What he did is he went to the end of the numbers, and he said, well, I know it's going to end with 100. And the number right before that is going to be 99. And he figured out that if you added up these two numbers, what do you get? Come on, add them together. What do you get?
101.
101. What do you think you get when you add 99 and 2?
101.
Do you think that's going to keep happening? How about 98 and 3? Doesn't that make 101? And I'm sure by then he was like, it's definitely 101 each time. And he was like, okay, so you add the first and the last one, and they add up to 101 every time. How many of those do you have? Well, if you're adding up the numbers from 1 to 100, wouldn't there be 50 sets? Yeah, 50 sets of 101. And that he multiplied in his head, because he's pretty smart. And he said, that's like 100 plus 1 times 50. So that's like 5,000 for that. And that's like 50. And that's 5,050. And he walked up to the front of the room after only a couple of minutes and said, it's 5,050. And the teacher was like, no. I want you to actually add up. And he's like, that's what they add up to. And that was the moment that they realized that little Friedrich Gauss, who turned into, Gauss is one of the most famous mathematicians of all time, was gifted in math because he figured out if you add the first one and the last one, and you just take whatever that adds up to and do that 50 times, if you're doing 100 numbers, it's half of how many numbers you have. He made this formula. Half of how many numbers you have times the first one. Would you agree U1 is the first one? All right. Plus the last one, which will always be another U1 plus n minus 1 times d. That's the formula. This is the first one, this is the last one, and this is half of how many there are. And look, that's the formula that's on your sheet. But they add these two u sub 1's together, and so here's the formula that's on your sheet. Find it, everybody. Look on the white sheet. Find it. It says S sub n equals n over 2, parentheses, 2u sub 1's plus n minus 1 times d. I don't want to be the teacher that just says, that's the formula, deal with it. I want to show you why it worked. Because it's the first number plus the last number. This was the first number. This was the last number. And when you add two u1's together, you get 2 u sub 1's. And this is just kind of the leftovers from that. And this is half of the numbers. So this is kind of cool because it'll work for every set of numbers that you ever want to do. So I'm going to do a weirder one. Let's say we were counting by 2's. 2, 4, 6, 8, 10, 12. And let's just do those. Let's say I just asked you to add these up. How many numbers are there? 6. 1, 2, 3, 4, 5, 6 numbers. So that goes here, and I'd have 6 over 2, which is the same as 3, times 2 u sub 1's, that's 2 times 2, because u sub 1 is 2, plus n, which is the number of numbers that we have, which is 6 minus 1, times d, the common difference. Do you get to get these? I'm adding 2 each time. Right now, use your giant brain. Figure out what that adds up to. Graham, what's the 6 divided by 2?
3.
Okay. 2 plus 2 times 2, sorry.
2 times 2.
Right here. I'm just doing this.
Oh, 4.
Plus, what's this next part?
5.
So now, finish it off. I'm doing the blue writing here. And let's go with Victoria. 5 times the 2
10,
plus the 4.
14.
And now it's 3 times all of that. Now 3 times 14 is, I wouldn't make a kid do that in front of everybody. So what the heck is that? Because that'll be the final answer. Now I'll take a volunteer for that one. 42 is correct. Very good. And guess what happens if you had just brute force added all these up? They'd add up to 42. But if I'm going to do it the smart way, I'm going to do 14, 14. Guess what happens when you add 8 and 6? 14. 3 sets of 14. See how that all worked out? They add up to 42. Anyway you add them, they add up to 42. All right, so that's called a sequence. No, it's not. Series. Very good. And it is so easy to get those two words confused. But if they ask you to do a series problem, that's the kind where you add them all up. All right, now there is a way to do this for geometric, and I want you to write this down. S sub n, u1, by now you should know what that means. R, which is the common ratio for a geometric problem, they're always multiplying by something, you know, to the n, minus 1. N is the number of numbers that you have. And it's all over r minus 1. Now, I'm not showing you how this one was derived, but that would take a long time. And this is the part of the hour where I need to get to the point so that we can, like, get into some actual problems and then turn you loose on your homework. So I don't have a great little Friedrich story for this, but what's the difference? This is the kind where you start with 2 and then you timesing by, let's say, 3. 2 times 3 is 6. Times 3 is 18. Do you get what I'm doing there? Times them by 3 each time. Now, how many numbers do we want to do? Well, let's say we added up the first 10 numbers. could say 10 terms. So if you know how to stick in numbers in a formula on this test, you win. If you can figure out which formula it is and know how to stick numbers in it, you're going to be fine. So Nora, what's u sub 1? 2. Mr. Washington, what is the r?
So B3.
It is. And if you're ever wondering how you get it, you go that divided by that. 6 divided by 2 gives you 3. Because it's the number you multiply by each time. Or the ratio 6 to 2, which is 3. Or what if you wanted to grab these two? Guess what you get when you take 18 divided by 6? 3 again. The ratio is 3. So I'm putting a 3 right there. And n is the number of numbers. I said to go to 10 numbers, so that's a 10. And r is 3 again. There's some times where it's kind of nice because there's two n's here. If I want, this n is 10, so this is s sub 10. It's the sum of the first 10 numbers. And now, it's just about being careful. From here, the only way you'll get it wrong is if you do something in the wrong order. Can you just do things in any order you want? Definitely not. One thing I can tell you, though, is that your denominator is completely separate from your numerator, so we can do that part. So what's the 3 minus the 1? You guys have a hard time participating. So it's painful for me, but I will help you because your class apparently can't speak out loud. 3 minus 1 is 2. And now I'm going to go 3 to the 10th minus 1. So 3 to the 10th, that's a really big number. That is an insanely big number. But before I finish that and put it in here, do you get if I have a 2 here and a 2 here that these can cancel? You remember that from one of our most recent tests, the one with the fractions in it? It was called rational functions test. These 2's will cancel. So really, I'm down to just this 3 to the 10th minus 1, which is a ridiculously big answer. Because even though the numbers were fairly small here, do you get I was doubling them? And so if I go to 10 numbers, the last number is going to be really big. Double 18, 36, double 36, 72, double 72, 144, double 144, 288, and then we have to add these all up too. Not only do we have to get to big numbers, we have to add them all up, and I'm only to the 7th one, and they get really big. So 3 to the 10th, and then subtract 1. Man, that seems wrong. Oh, I know why it's wrong. I was starting to double all of a sudden. This was times 3. So this should have been 18 times 3, and that's not 36. So these numbers are even bigger than what I said. Sorry about that. You times by 3 to get each number, but you don't have to do all that. You just have to do the formula. So grab your calculator. If you don't have one, you are going to be allowed today to use your your iPad for this if you want, because these are just simple powers. And the iPad is fine at doing 3 to the 10th. 3 to the 10th. And then I subtract 1. I got 59048. Can anybody verify they had that before I said it? 59048. Okay. So we should do another one like that. We go to this page. This is not what we just did, so I want to skip this page and go to a different page. This is the story about Carl Friedrich Gauss, but he went by Friedrich. He added these numbers, you know. All right, so we're going to the next page. On this one, they're telling us that you're going to start with 26, and you're going to subtract 2 each time. We aren't even making a list yet. But if I did, it would start with 26, and then I'd subtract 2, so it'd be 24, and then I'd subtract 2, and it'd be 22. And do you think I want to do that forever? Of course not. But I think one of the smartest things you could do is make a list of the first three terms. So everybody, please do that. Make a list of the first three terms. That way you're like, okay, I understand what I started with and what's happening. And subtracting 2 each time. Okay? Now use this formula that is printed for you. It'll save you the pain of having to copy it from the sheet. Use that. Stick the numbers in. By now you should know. If I want S sub 32, they want the sum of the first 32 numbers. Use this formula. Stick in N is 32. U sub 1 is our first number. They say it right on the screen. I'm going to pause for a minute while you stick all of those in and use a calculator to get the answer. Then I want you to turn it my way, and I will walk around, and I want you to hold your calculator up to me to show me what you think the final answer is for the sum of the first 32 numbers. And don't be surprised that it's actually kind of small, because do you get that the numbers are getting smaller and smaller and smaller, and they're actually going to go into the negatives? If you keep going down by 2, eventually you get to negative numbers. So when you add this all up, it's not very big. All right, use your calculator or your iPad and be prepared to show me what you think the answer is. So the results, about half the kids were getting it right. And here's how you do it. I want the 32nd term. So right away, my n's are 32. Do you get I have 3 places where there's an n? Those are all 32s. N was our number of terms, and it was 32. Next is U sub 1. That's easy. It's just the first thing, which is right there, 26. And then D is the common difference, and it was negative 2. 31 times negative 2 plus 2 sets of 26, which is 52. I would do some of this in my head. 32 divided by 2 is 16. Okay, I believe there's enough people are saying something's wrong. Aha, 32 minus 1 is not 33. I get it now. 31. There we go. And now, I would do that much in my head, then I grab my calculator and do the rest. That's what I do. I know some of you are just going to type in absolutely everything into the calculator, but I think it's harder. Because I can do double 26 in my head. And I can do 32 minus 1 in my head. Well, apparently not. I had 33, but... All right, so then this is negative 62. And this is 52. And that basically makes negative 10. So 16 times negative 10 is negative 160. And again, about half of you had that right in the first place. Okay. Next. Without any help. That's n. Find the sum of the first 47 terms using this formula. Pause for a second. Notice it starts with 23. And see how many kids can do it now. Hopefully we can get up to at least 2/3 of you getting it right. Okay, so we're trying to find, n is 47 in this case. And there's a 47 here. Okay. So next up, Victoria, what's the U1?
23.
Yep. So I need 2 times 23. Some of you guys probably did that in your head and just went 46, and that's what I'd do. Because 2 times 23 is 46. And then 47 minus 1 is 46 times the common difference, the D. Christian, what's the D?
5.
Yeah, we're adding 5 each time. And from there, I would totally use the calculator. 47 divided by 2 is not nice. And 46 plus 46 times 5 is not nice. And I get a calculator out, and I type that in. So here's my calculator. Clearing it off. I'm going to go 47 divided by 2. That's 23.5. And then I take 23.5. Clear this off. times 46 plus 46 times 5. I could have made a mistake here, but I got 6486. Did anybody else get 6,486? Uh-oh. Then what's wrong? Aurelia?
Is the common difference 5 if it's jumping from 28 to 31?
Oh no. 28 to 23 is 5. Dang. And that's not plus 5. That's cruel. Oh, I think the teacher just messed up. Honestly, the teacher added 5 and then they added 4. So that should have been a 32. And then it would have been adding 5. Because at this point in the lesson, we're not trying to trick the students. So, oops. But, yeah, if we had to do it, you would not be able to use the formula that we have. What? Oh, you're right. It's actually 33, not 32. Thank you. So the moral of the story is the problem was goofed up. But using everything that we had, I think I now still have the right answer for what we thought it was, which was adding 5 each time, even though it wasn't really adding 5 because of that one little oops. And I'll fix that for next hour. All right. Well, tell me this. Would you agree that it's 23.5 at the beginning? Did you have that? You didn't? Well, was it 47 numbers and divide by 2? Is that not 23.5? I'm going to double check that. 47 divided by 2. That's definitely should have been a 23.5 in the front. So if you have a different answer than that, you were doomed right there. Next. The 2, oh, I do have a, do I have a mistake? I'm double checking this. Nope. 2 sets of 23 right here. 2 use of 1, so 2 23s, and that is 46, so that's right. And then this is 47 minus 1, which makes 46, so that was right. And the common difference was 5, other than the fact that this number was screwed up. Okay, so I'm just double checking myself to make sure I didn't mess anything up. 46 times 5, and then I'm going to add another 46. Could have just done 47. No, 46 times 6 would have also worked. 276 times 23.5. I'm now more certain than ever that the answer is 6486. Okay. All that is a hard formula. Sticking numbers in a formula can be hard if the formula is hard enough. Let's go to this page. This is the kind where it's multiplying by something each time. Now I can tell because they changed formulas. They changed formulas to this one where you've got an R, the common ratio. N still the number of numbers that you want to do. R is again the common ratio. So what's the common ratio? It's right there, 0.4. So I'm going to go put a 0.4 in the right spots for where the R is. N is they want the 13th one. I know some people are lucky numbers 13. So that's your N. N appears in 2 places in this formula, right there and right there. All right, everybody figure that one out. Abby, what's u sub 1? It's on the screen. Just look close. Yep, it's right there. So it's 250 right here. And then I got to do R to the N. Iris, what is R in this case? Yep. So now I go in here and I go 0.4 to the N. Iris, what's the N in this case?
13.
Yep, the number of numbers. It's 13. And minus 1, anybody can do that. And then R minus 1 on the bottom. Victoria, what's the R again?
0.4.
Good. So 0.4 minus 1. Put that into your calculator and see what you get. I would do some parts in my head, like I'd do that in my head, but if you're not good at it, then do it on your calculator, that's fine. Okay, so we got 416.7 on that one. That was our final answer of what they all add up to. You can be a ninja with using formulas for this lesson. This is the part where I'd like to just get to your homework. Oh, wait, one more thing. Infinite sums, my bad. It's on your sheet. The last formula on the sheet, and this is the last one we haven't talked about, is about infinity. And you might be like, Mr. Server, you cannot add up an infinite number of things. But yes, you actually can. It doesn't seem logical if you just say like 1 and then 5, adding 4, 9, etc. Add them all up, an infinite amount of them. Because it feels like you should just say the answer is infinity. Because you can't get the answer for that kind. You can only do this when you're multiplying by a decimal. That's what this means. Your R, your rate, has to be between 0 and 1. So if you have a series like this, 2, cut it in half. 1, cut it in half. 1/2, cut it in half. 1/4, cut it in half. 1/8, cut it in half. 1/16, ... That kind, where the thing you're multiplying by is 1/2, you know, the R equals 0.5. As long as your R is less than 1, you can add up this kind to infinity. And it usually freaks people out that you can add up an infinite number of things and get an answer. But I want to this is probably the moment where I'm stretching you the most to make like a theoretical understanding of something. Do you get if I right this minute am 20 feet from the door, would you guys agree that's in the neighborhood of 20 feet from the door? Okay, so if I want to get out that door, do you agree my distance will have to cut in half? The distance to the door has to go halfway, right? So if I said I'm 20 feet from the door and I go halfway, then now I'm at about 10 feet from the door. Do you get I can just repeat that process? So then I'm halfway from the door, it means I'm 10 feet from the door, I can go half of that, which is 5 feet. So I started with 10 feet, now I'm gonna go 5 feet. And do you get I can keep cutting it in half over and over and over and over and over in an infinite series? If the numbers are getting smaller and smaller though, you know what it adds up to. It has to add up to 20 because I'm gonna get out the door. Know what I mean? It has to add up to 20 because I was 20 feet from the door. So 10 feet plus the next one was 5 feet plus another 2.5 feet plus another 1.25 feet. I'm getting halfway to the door, halfway to the door, halfway to the door. And theoretically, you should never get to the door. Because you just keep going halfway there, halfway there, halfway there, halfway there, and it's like you'd never get there. So here's my trip to the door. I started 20 feet away and I went 10 feet towards the door. Then I went 5 feet. Then I went 2.5. Then I went 1.25. These are cutting in half. And if I add them all up though, you know what it adds up to? It adds up to 20. So here's the formula that does it. You take your starting number and you divide by 1 minus the rate. What was my starting number on the door problem? 10. Because that's how far I went on my u sub 1. My first term, I went 10 feet, and then I stopped. Divided by 1 minus the rate. And what was my rate? Well, I was going halfway each time. You only have 2 numbers to put in. It's hard. What'd you start with, and what was the rate? Now I just simplified. 10 over 1 minus a half is a half. And what's 10 divided by half? It's 20. And that's right. I go 20 feet. And that's what all of this infinite number of numbers adds up to. It adds up to 20. And if that isn't bothering you, it's because you aren't really thinking about it. You are adding an infinite number of little decimals. And it's coming out to exactly 20. That's weird. If you aren't realizing that's weird, that's weird. But yet we know that I get out the door. That's why I use that example, because you know if you start 30 feet away from the door,
You walk 30 feet.
you're gonna go halfway there, and you're gonna go halfway, and you're gonna go halfway, and it's true. In the end though, you walk 30 feet. So even if it is an infinite number of little adds, we know it actually adds up to a total. And that's this formula, the last one on your sheet. S sub infinity is U1 over 1 minus R. You've learned everything. So here's one where they started 2,000 feet from the door. No, wait, they actually started 4,000 feet from the door, or some bigger number than 2,000. And there, wait a minute. This one, is it really cutting? Well, I don't know what it's cutting in. It's not cutting in half. So I take this divided by that, and I'm going to see what it's multiplying by, because it's not multiplying by a half, or it'd be 1,000. 1,500 divided by 2,000. It says 0.75. Do you get I'm multiplying by 0.75? I'm going to try it again. 1,500 times 0.75. I'm going to just see if it actually worked. 1,500 divided by 0.75. No, times, sorry. 1,500 times 0.75. 1125. Sweet, it worked. I'm multiplying by 0.75 each time. How do I get the 0.75? By 1,500 divided by 2,000. That's called the common ratio because it's a ratio of 1,500 to 2,000, which is 0.75. So how do I do this? Well, what number did I start with? What was my u sub 1? Dashel?
2,000.
2,000. Nora, what's 1 minus, what's the R? R is the common ratio, the thing you multiply by each time. 0.75. If I were doing this, I'd do this in my head. What's $1 minus 75 cents? And then I'd take my calculator. I can do this in my head, but because the 25 is really 1/4, and if you divide by 1/4, you're timesing by 4. So I know the answer is 8,000, but I know you probably might have needed your calculator to do that. That all adds up to 8,000. That's what that means. Okay, so now I have taught you how to use all these complicated formulas on this sheet, and now this is the part where we take this and move it to a worksheet. So find the worksheet that is posted for today. It is a Schoology quiz. Open up the Schoology quiz. And I'll start it with you. Series is where you add up all of the terms. I've got about 3/4 of you are in it right now. If you're not in the Schoology quiz, please hurry up and get there. It's easy for me to tell from the front here whether you're in there. So get in there, please. Seven plus 3 plus 7 plus 11 plus 15. Christian, what are they adding each time? They started with a 3. They add 4 each time. So, Christian, would you read me the questions about number 1? S sub 14. That means the sum of the first 14 terms. Noah, it's a big nasty formula. Is this arithmetic or geometric? Look it up on your sheet. It is arithmetic. Noah, could you read me the formula? It starts with S sub n, which is S sub 14. Keep going.
Parentheses
Good. And now let's fill in the numbers that we have. Aben, what is n? It appears here and here. 14. Now, I hope nobody in here does 14 divided by 2 on their calculator, because you could probably split 14 in half all by yourself. Then you got 2 times u1. u1 is 3. 2 times 3 is 6. I can do that in my head. Don't do everything on the calculator. N minus 1. N was 14. Oh my gosh, it appears again in the formula. 14 minus 1 is 13 times... Common difference is 4. Okay, 4 times 13 is kind of hard. Do that in your head. I'm impressed. Put this all together. You got your final answer for your first problem. All right, that's all I got for you for the video for today.